We are in a early two-door. I believe this is a 2007. This Jeep has a couple of oddities. One, it's a two-door. Two, it was a manual transmission. And it doesn't have a whole lot of options. We got roll-up windows. So even though this was a manual transmission JK and it did not have a Prindle on the dash, our CAN module activates it. And yes, it's fully functional. And it even shows current gear when you go into the tap shift mode. Let's talk a little bit about the considerations when doing a two-door swap. Some of the first conversions we did were two doors, and there's really not a whole lot of difference between the two-door and the four-door mechanically. I would say the biggest considerations are, one, the exhaust system. In the four doors, we run the passenger side exhaust pipe above the cross member, adjacent to the fuel tank, and there's a fuel tank shield there, and then under the transfer case and out. That way you can run full skid plates and nothing sticks down below the cross member. As you know, the stock JK and some of the other conversions run the pipe in front of the cross member and underneath the transmission. So you lose a little bit of ground clearance there, and it can be a little more difficult to fit a skid plate, especially if you want flat skids. Another consideration is the drive shaft length. As you know, a two-door has a much shorter drive shaft in the rear than the four-door. So if you lift a two-door, and let me explain, when you lift a JK, because the control arms work in an arc, it pulls the axles closer to the center of the vehicle. If we move the transfer case back 3/4 of an inch, you lift the JK, a couple of things are going to happen. One, your rear drive shaft's probably going to be too long, and two, the drive shaft angle is going to be steeper because the two-door is a short coupled vehicle. So when you raise it up, the angle of the drive shaft is going to be greater than in a four-door vehicle where it's longer, so you can move the axle further and not have the same angularity. Therefore, if you have a 4 or 6 inch lift on a two-door with stock control arm, you're probably going to have a problem with vibration, but you're probably going to have a problem with vibration even before you do the swap. I've never been able to figure it out. I think it's more of a art than science. But I've had lifted two doors that don't vibrate at all. Then I've had two doors with a 3-inch lift, and no matter what you do, they vibrate. It has to do with the dynamics of the suspension and the angles, and it's just difficult to figure out. Another concern is articulation. If you've got a ton of articulation in your Jeep, which a lot of them do, that drive shaft's going to have to work harder. And if it's limited to a few inches of travel, you're probably going to be okay. But at the extremes of travel, that CV, if you have a CV shaft, or that R Zeppa, could be under a lot more stress, and you might notice vibration. So those are the two biggest differences, in my opinion, between a two-door swap and a four-door swap. If you stick with about a 3-inch lift, and you can run some pretty big tires with a 3-inch lift today. Mopar and a lot of others have Highline fenders. You can get 37s, maybe even 38s under a 3-inch lift, and I like that low center of gravity. If you go with a quality suspension system that lifts the vehicle 3 or 4 inches, the manufacturer knows that those axles have been pulled in. So they're going to supply you with control arms that are longer to push that axle back and center the wheel back in the wheel well. That's a quality lift. If you're running stock control arms and you lift that Jeep up, you're going to pull those wheels forward. And it's not only going to look funny, but it's going to change the dynamics of how your JK drives. Now, going to adjustable control arms is even one step better, because now you can actually fine-tune and get that axle exactly where you want it. Adjustable control arms are going to give you that extra advantage to set your wheelbase. That's the distance between the front and the rear wheel, to avoid crabbing or ESP. And I'll mention something about that. If you got especially a short coupled vehicle and you're fighting a strong side wind and your wheel is tilted over, you might have an ESP light come on. There's nothing wrong, but what's happening is the steering angle sensor inside the steering wheel is not jiving with the wheel speed sensors. There's 4 of them, one on each wheel. So the computer knows the direction of the vehicle through the wheel speed sensors. When they run differential speeds, it knows you're in a left arc or a right arc, and ESP is always looking at that. So whether you're fighting a strong side wind or you have your wheelbase off, you've installed the axles and they're crooked or bent, ESP is going to pick that up. They're going to see that difference between what the steering angle sensor says you're doing and what the actual vehicle direction is as read through the wheel speed sensors, and then you're going to get a light, like an ESP light or ABS light, whatever. So suspension tuning becomes more critical on a two-door because it's short coupled. The axles are closer together. You raise it up. Same thing holds true with the track bar. If you go with a stock track bar that is not adjustable and you raise your JK, it's going to pull that axle over to one side. Some of the manufacturers of the economy kits will give you an offset bracket that basically tries to put the track bar back where it was. I've actually seen the track bar mounts break off when guys raise their JKs and they don't correct the geometry. But again, if you can afford an adjustable track bar, that's top of the line. That's going to let you put that axle right back where it belongs. And where it belongs is right in the center when you're at ride height with all the weight on your JK. Some of the advantages of the two-door, in my opinion, are on some of these tight trails. Having the shorter wheelbase means you have a better turning radius. You have to remember, when you put a lot of power into these, you have something called bump steer, torque steer, brake steer. This is something that I've wanted to talk about, and maybe I'll do a video on, because we see a lot of issues with this. As your front axle goes up and down, both the drag link and the track bar run in an arc. You want to have those two pivot points the same distance from ground level. If those are separated, let's say the drag link, you flip it up and it's 2 inches higher because you got a high steer now. What ends up happening is the track bar and the drag link work in two different arcs. What you end up having is a steering input as the axle goes up and down. You've all felt it. You hit a bump and the steering wheel jerks in your hand. In an extreme case, it can set up death wobble. When you hit the brakes hard and you dive, meaning the front end comes down, that'll jerk the steering wheel the other way. You take a Jeep with 202 horsepower and you put in an engine with 450 horsepower, you got it raised up 4 inches with real floppy suspension, you nail it, the front end comes up 5 inches, and the steering wheel turns enough to practically change lanes. So these are the things that you need to look at in a two-door. Other than that, the two-door build is virtually identical to the four-door. The whole front of the JK is the same. So the engine install, the easy mounts, the tranny mount, cross member are all the same. What this customer thought he was getting was a 2013, I believe it was a 13 L94 from an Escalade, engine and transmission. Turns out that wasn't the case. Turns out he ended up getting an L92, which is a 2007 and 8 Escalade engine and is difficult to work with, and an early model transmission, which again is difficult to work with. And we're going to talk a little bit about that because it is important. The L92, and I worked with EFI Live back in 2007, had an early Gen 4 operating system, and they did some odd things. GM was still sorting out the Gen 4 controllers. This happens to have a 384 controller, which is a 2008 module. One thing about 7 and 8 powertrains is if you run a 7 computer, you run a 7 transmission. If you run an 8 computer, run an 8 transmission. Try to keep them matched exactly from the vehicle they came from, or you might have issues. They were very specific when you marry that engine and transmission together. That's one of the reasons I highly recommend you go with the 10 or newer powertrain, because 10 or newer you can mix and match the E38 and the T43. The T43 being the transmission controller and the E38 being the engine controller. Pretty much everything from 10 up has a 238 ECM, or engine control module. That's the last 3 digits of the service number, and the great thing about that is you can have a 2010 engine control module and a 2016 transmission control module and it worked. Not so in 7 and 8. I've had guys try to take 7s and 8s and mix them with late model transmissions and vice versa, and it never works right. Sometimes you can get it to work, but it never works right, in my opinion. You end up getting some transmission flaring between gears or oddities in the shifting profile. Try to avoid that. And in fact, try to avoid 7 and 8 engine powertrain combinations to begin with. The L92 is an awesome engine. The L92 is the early 6.2, had VVT. In 2009, they added flex fuel and called it the L9H. 2010, they added AFM, or 4-cylinder mode, and called the L94. Basically, they're the same engine other than those features. The L92 did have a different intake manifold, different fuel injectors because it did not have flex fuel, different map sensor, so it had a different speed density system. So when you add all this up, it is a little more difficult to install an L92. What we have had very good luck with is you can take an L92, change the map sensor out to a late model Bosch style. That'll change the speed density to the newer style 10 and up operating system. The oil pressure sensor is different, but you can just buy the late model oil pressure sensor, screw it in the back of the lifter manifold, and you're good. Then you can run a late model transmission like a 10 and up, which have a lot of improvements over the early transmissions. So essentially what you're doing then is you're turning your L92 into an L9H. Now the L9H is an L94 without 4-cylinder mode. If you're into performance, you might want to look at the L9H because you don't get the AFM lifters. And if you really want to push the thing and rev it out, it's better not to have those AFM lifters. In my opinion, we've run dozens of L94s and L99s with AFM. We haven't had any issues with them. 7, 8, yes. We had some of the AFM lifter problems that we had discussed earlier, but not in the late model L94s. Now in the early days, these were difficult to get running and running right. And like I said, I work with EFI Live, and we ended up doing some logging and testing, and they would send me lists of data that they could analyze. And it turns out four-wheel drive was a problem. When we didn't have a valid four-wheel drive signal over the CAN, the engine would go into a semi-limp mode. Another issue we had was the starter relay check. GM incorporated something called the starter relay check, and what it did was if somebody pulled the starter relay out and tried to jump it, it would sense that there was no continuity across the trigger of that relay, and the computer would think somebody was trying to steal the vehicle, and it would shut off the fuel. So the engine would start and die, start and die. Well, EFI Live ended up writing some routines to eliminate the starter relay check, and it worked in 2009 and later. It did not work all the time in the 7 and 8 operating systems, and I can't tell you why. It has something to do with the complex checksums. So what we ended up having to do was install a resistor across the starter relay trigger wire going into the computer, so that the computer thought that there was a relay in circuit, and then no more problem, the engine would start and run. The transmissions, just like the 8L90s in 14 and 15, in 2007 and 8, had some issues. We're talking about the 6L80. Great transmission, but GM learned there were some oiling issues and some programming issues that they eventually sorted. And I should back up. The TCM, or the transmission control module, in Gen 4 engines are separate from the engine control module. In the Gen 3 engines and the early JKs, they use what's called a PCM, a powertrain control module. So that single module controls both the engine and the transmission. When GM went to the Gen 4 engines and now the Gen 5, these things have so much computing power. And let me give you an example. A Gen 4 engine can have 2 megabytes of data in just the engine control module, where a Gen 3 only has about 200 kilobytes. So they're massive, and the Gen 5s are even bigger. So what they did is they separated the ECM and the TCM, and they made them communicate over a CAN bus. If you had an early model Gen 4 engine with a 4-speed transmission, you had an external T42 transmission controller. It was a small module that sat off to the side, similar to what the 8L90 does. And that communicated with the transmission, and then it communicated via the CAN to the ECM. So it was a really complex setup, and one of the reasons we dropped support for the 4-speed. A lot of wires involved. When you got to run all the power, solenoid, Prindle, IMS, all these different signals external from the transmission into it, it just made for a more complex harness. So what GM did, which I thought was brilliant, is they put the TCM inside the transmission. Now all we got to do is run CAN in, CAN out, a brake signal, and a couple of power wires, and it works. We're going to hit the mountain, and we'll talk to you soon.